Okay, we're in topic 2.1, using variables to write expressions. How can you write an algebraic expression? Donnie bought CDs for $10 each. How can you represent the total cost of the CDs? We are going to use a variable, so you're going to want to write this definition down. Right here, variable is a quantity that can change or vary and is often represented with a letter. Variables help you translate word phrases into algebraic expressions. So we use a variable because we're not sure what the number is, or it may change, and no matter what it is, we can plug it in to find a total. So in Donnie's case, we use the variable n to represent how many CDs he bought, and then we write this algebraic expression. So another vocabulary word you want to make sure you write down in your math notebook and your homework is algebraic expression. This is a mathematical phrase that has at least one variable and one operation. So one variable, letter, representing a number, and an operation, addition, multiplication, subtraction, division. In this case, the total cost of the CD is represented by 10 times n, or 10n. Now in the past you've always written multiplication like 2 times 5 or 10 times 3. Now when we're writing algebraic expressions, you want to write, well, we could write it 2 times 5. We could also write it 10 with a dot times 3. Or, if we wanted to, with parentheses, 2 times 5 to show we're multiplying, or 10 times 3. Now, like I was saying, if we use a variable, a letter, and say instead of 10 times 3 it's 10 times n, we're going to write 10n. And when we see the number and the letter side by side, we know it means multiplication. This is to keep confusion down. 10 times n is very confusing because, well, x could be a variable instead of a multiplication sign. So we don't use that in multiplication for a multiplication sign anymore. We want to just put the letter next to the variable. So in Donnie's case, trying to figure out how we can show the total cost of the CDs, what does n represent? Why do we have n in there? Why is it 10 times n? What does n stand for? If you look over here at this table, n stands for, right here, n, the number of CDs. If I have 1 CD, it's 10 times 1. If I have Donnie bought 2 CDs, it's 10 times 2. 3 CDs is 10 times 3. If Donnie buys 4 CDs, it's 10 times 4. Whatever the number, whatever the variable may be, that's n. We just multiply 10 times that. So that would have been the algebraic expression to show how you could find out how much Donnie spent on CDs. Look at the other examples on page 32. This gives you an algebraic expression and helps you understand which operation you would choose. Word phrase, and then helps you choose which operation you're going to write when you write the algebraic expression. So the first one, $3 more than cost C. Well, more than, here's your clue that it's going to be addition. More than means add. Now we had cost C first, and then we're going to add 3 more dollars, which is why it's C plus 3. The second one, 12 pencils decreased by a number n. Well, decreased, what do you think that operation is going to be? Subtraction, of course. So we have 12 pencils first, 12, decreased by a number n. We don't know what that number is, we just know it's decreased by that number, and n is the number that it's decreased by. The next one, 5 times a distance d, times Well, of course you know that would be multiplication. So they have 5 times D, how you used to write it, or how I would prefer you write it, 5D. Number 4, A apples divided by 4. It says divided by. So of course it's going to be division. We have A divided by 4, or is a fraction, A over 4. If you remember, a fraction shows a division problem, so A is on top because always numerator, top number divided by denominator. And the last one, 5 less than 3 times an amount X. So we have less than and times in here. We have two operations, less than, subtraction, and then multiplication. I know it says 5 less than first, but it's 5 less than what? Something you already have. 3 times an amount X. So we have 3 times an amount X, and then we take 5 away from that. Notice the order. Okay, let's look at a few more examples here in guided practice. And why don't you pause me right now and take 5 minutes, 10 minutes to try numbers 1 through 4 here that you see on the screen, and use the other examples on page 32 to help you figure out the order, the operation. And then when you're ready, push play again and you can see the answers. So number 1, the difference of a number T and 22. So that would be T, difference meaning subtraction, minus 22. Number 2, M bicycles added to 18. This is, remember, it's M bicycles added to 18, so this means I have 18 first, and then I'm going to add M bicycles, however many M may be. Number 3, 11 times a number Z. Now remember, times obviously means multiplication, so we're going to have 11, and to show multiplication to a variable, we'll just write 11Z. Number 4, 4 less than 5 times a number G. So we have less than, subtraction, and times multiplication. 4 less than 5 times a number G. Yes, we need to take 4 away from, but first, we're not going to take it away from 5, right? We're not going to take it away from G. We're going to take it away from, or 4 less than, 5 times the number G. So 5 times G comes first, and then we're going to take that 4, or 4 less than. And you would read that 4 less than 5 times a number G. Okay, for your homework, write an algebraic expression for these situations. Number 1, 8 less than 2 times a number. And number 2, n more students than the 8 students sitting in each of the 3 rows. Do your best, look at the examples, look at what you've written on your homework, and don't forget to come to class with a question to ask. See you tomorrow.